script. If you guys have any problems, cannot see anything, just let me know, okay? If you click on the R script, this area will pop up, right? And this is the part that we will type all of our commands of the script, and you guys can save all the commands and as a text file and use it later, okay? So that's all the 4 parts for the R Studio that not have in R. If you use R, the only part that will have is the console area. That means you cannot save anything, basically. All right. And if I switch to PowerPoint slide, can you guys see my PowerPoint slides, or is it still on the R Studio? Anyone see my PowerPoint slides, or is it still on the R program?
It is maybe still on the R program.
R program, okay.
Yes.
Okay. Now it's supposed to be the PowerPoint slides, right?
Yeah, but yes.
For some reason, I cannot use both. That's interesting. Anyway, so switch any. Okay, so all this function, let's first use R as the calculator. Okay, that means just stay with the R may be better. Okay, if you want to use R as the calculator, you just can type, like for example, 7 plus 3, and then you just click run, and the result will appear in the console part that the result 7 plus 3 equals to 10, right? Or you use it as 2 minus. You can type the commands in the console area, and you also can type the commands in the R script area. If you want to save it, make sure that you type it in the command in the R script area. If you don't want to save it, you can just type in the console. For example, 10 minus 3. If you type the commands in the console area, after you type, you just click enter and you get the results. But if you type in the script area, 10 minus 3, you have to click run. Get the same result. Right? Or if you want to multiply, you just use the asterisk. 10 multiplied by 2, 20. If you want to square root, for square root in R, we use the SQRT 2. For example, square root of 2. And then run, you get the result. So R can be your calculator. That's the basic one. Another important thing for R is that if you just type like this, you cannot recall it. You have to retype it every time. But if you want to recall it for later use, you need to create an object. Okay, to create an object, we're gonna use the symbol. For example, let's call the object A. And we use the symbol like this. Whatever appear on the left of this symbol is called an object. for example, an object A. And then you can create a value like A equals to 10. Then you can just run. And you can just recall it A. If you type A again, you can get the same value that you have created. A equals to 10. Right? If we type A with the small letter, can we get the same value 10? No. It shows as the error. Object small letter A not found. That means in RStudio it is case sensitive. So you need to be very careful when you use R, the small letter, the capital letters. Okay, make sure that it is accurate. All right. Now, another thing, if we create the object, for example, a capital X, we want the capital X to be the range of value from 1 to 10. 1 to 10. If you recall the capital X, you get the result, the range of letter from 1, 2, 3, 4, 5 until 10. But if you create the capital Y with the terms, for example, 1, 10, minus 1. I want you guys to guess first, what would be the result for this object? What would be the range for Y? Anyone would like to try? You can just send your answer in chat, I think. Anyone?
Okay, anyone, maybe you can try to input that in your own R programming and share the result in the chat meetings.
Anyone?
Maybe anyone still confused, or maybe I can maybe
Oh,
I participate.
if they cannot talk, if they want me to restart things, I can. Just let me know, okay? Because I cannot see them, so I'm not sure what is that status now.
Okay, is there anyone can guess the result? Maybe guys, anyone can guess the result? Okay, so there is from Wafi, Miss.
All right, that's the correct answer. If you put 1 and then 10 minus 1, what the R do is that to handle the number in the bracket first. So the result will come from number 1 to number 9. That's very good. Thank you. How about if it's not 1 in the bracket, but it is 1, 10 minus 1? Can you try and see the difference? Well, number 1, colon and 10 minus 1, no bracket. What's the difference?
Okay, guys, maybe what's the difference between the line 10 and 11? You may answer to the meeting chat, maybe, guys. Okay, Miss, there's the answer from Wafi.
Yeah, 0 to 9. Let's see if we run, and it is correct, 0 to 9. That means without the bracket, minus 1 will happen to both 1, 1 minus 1, so it starts at 0, and also 10 minus 1, that's equal to 9. That's why the range becomes from 0 to 9. That's good. All right. Another thing that we should mention about R is that for some reason I cannot just share my computer screen at one time. Sorry for kind of switching back and forth. All right. Another thing for the data analysis, any programs, before you do the analysis, you have to make sure that the data is in the correct data type. And in R Studio, there are many, many data types, but the main one, there be 5 main data types that we use regularly. The first one is the character data. Character data type is anything with the alphabet or the combination between alphabets and letter. For example, home address, mailing address, your email, that's the character. Something that you don't want to compute, you don't want to calculate at all. The second type is numeric. For numeric, it is the real numbers. Real numbers can be in decimal or no decimals, but it just open from 0 to infinities. Okay. Another type that also the number is called integer. Integer is only for the whole numbers, no decimal. For example, the quantity in units, 1, 2, 3, 4, 5, no decimal at all. And for the complex is kind of like something in formula. For example, you have revenues equal to quantity multiplied by selling price, right? If you know the selling price, but you don't know the quantity of the combination, revenue equals to quantity multiplied by $5, for example, that whole thing is called complex. There's the one value that you don't know, okay? And the last type is called logical, or another program we call Boolean. For Boolean, it is just true, false, yes, and no, something that logic and have only 2 answers. You can check the data type in R using class and bracket function, okay? So let's see if we create an object and we would like to check the data type. For example, we have created the object Y, right? In line 10, we create an object Y. And we would like to check what kind of data type of Y. You just check class and then in the bracket with the capital Y as you create it. And then let's see what's the result. Oh, we do not see Y. That's interesting. Oh, because I did not run Y. That's why. I haven't run the command in line 10. So let me run that first. And now let's see class for Y. Y is integer. That means of the number from number 1 to number 9, it is the number with no decimal. That's why the data type is identified as integer. How about if we create an object A equal to 10.55? Create that object first, and then check for the data type class of object A. It should be numeric, right? Because it had decimals. Doesn't matter how many digits of the decimal, you have decimal, so it is identified as numeric. If you create an object B, let's see, my and run. You cannot run here because it detects this part as something as the object. So whenever you create the object with the alphabet, make sure that you put it in the quotation mark. Okay, let's try again. And now class of object B should be character or string, right? Any questions? What if I create an object C with 10.5b? What kind of data type for this object C? Integer, numeric, or character, or complex?
Okay, guys, anyone can guess it maybe via uh, Zoom chats, or maybe you can answer it directly.
All right, we have the answer. It is character. Let's see. It should be character, right? That's correct, of course. Even though you have both combination between the numeric and the character, everything that you identify in the quotation, it will usually be classified as character automatically. All right, that's good. So now I think we can move on to the main part, which is the data transformation. For data transformation, basically it's just to prepare your data to make sure it is in the format that you want to use to analyze, to answer the questions. That's all. That's the purpose of data transformation. For our studio to do data transformation or any data analytics task, the package that you need to install first is called tidyverse. For our studio or our programs, if you use that package for the first time, you have to install it first. After you install it, you have to download to your workstation. That's for the first time that you have to do both install and download. But if you already installed that package and you use it the second time, you don't need to install again, but you need to load the programs to your workstation, okay? To do that, let's see. Okay, to do that, you can check if you have that program installed already or not by on the right side of our studio. Did you guys see the word packages? If you see the word packages, you just click on the tab packages and the search bar here. You can just type tidyverse, Tidyverse. If it's shown, that means you already installed it. If nothing happened, nothing shown, you can just type the commands to install the packages. And our studio is very user-friendly. After you type some part of the commands, it already showed the suggestion. We want to install the package for the first time, so install dot packages and type the packages that we want to use, tidyverse. Okay, install dot packages, and then in the bracket, the name of the packages we want to install tidyverse. And after that, you just click run. I can install again too. If you already install it, then never mind, you can install it again. Oh, I forgot that. Tidyverse. And run. I forgot the quotation. For install.packages, you need to put a single quote and then it will run. When it runs, you may see the red letters with the warnings and so many things going on. As long as it is the warning, just warning. Don't panic, okay? Just let it run. Okay, until you see the word package tidy successfully unpacked, and get this ready. That means you already installed the package. So I hope that you guys can like run along and let me know if you have any problems or it's just too fast or you just cannot follow. Just let me know, okay? Okay, can we continue? Anyone?
Is there anyone still not success in
Just
adding?
install it the package.
Oh, there is a Romelu, Miss.
Oh, you cannot. Okay. Can you make sure that you spell it and put the single quote inside? Can you try with the single quote in? If you cannot, then another way is just use the double quote sometime. Either single quote or double quote. It's really sometimes just depends on the computer setting. So try both. Does it solve the problems?
Okay, for Mas Romelu, does it solve the problem to install the package? Still
Still,
can.
okay. Let's try copy and paste this one. Just copy and paste. Let's try. If it just show the warning, the word warning, it's nothing to worry about, okay? If it's shown as error, then that may be the problem. Okay, that's good. All right, any other problems installing? Okay, after we install, now we have to load it to our workstation. So just type library and the package name. Now we don't need the quotation. Library tidyverse. This library thing, you need to run it every time you use our studio, okay? And after you type, then you just click run and wait for it. Any issues, any errors? If any issue, just let me know, okay? No issues, right? Okay, now we are ready. For the class exercise today, we will use the pre-installed dataset. So let's install another dataset. I think it's already pre-installed in Area Studio. So let's just start from library. And the dataset we will use is the NYC flights 13. It is the dataset that pre-installed in our studio. So just type this and see if we can run successfully. No error message, nothing, correct? So we want to check if we really have the data set loaded to our workstation. We're gonna use the function view with the capital V, IEW. Just make sure it is capital V, okay? And in the bracket, this data set is called flight. I think no S, flight, or no with S. And then just run. When you type the command view, it will show the data or the result on the new tab. Everyone see the data after you run view? Okay. It is always good idea to look at your data first to just see what you have, right? All these columns, all these rows. It summarizes the table, the data that we have down here. 1 to 9 of 336,000 entries. That means you have about 330,000 records. Okay, with the 19 columns. The columns just represent variables. We have year, month, date, departure time, scheduled departure time, departure delay, all the flight information. Okay, that happens in. All right, that's the data we have. Okay, now come back to the R script. And let's see what we should do for the first part of data transformation. Okay, we already load everything. And we already looked at the data. Okay. Now, the first part of data transformation is to just filter. Like the data set that we have flights, it's about like 300,000 of records. That's quite a lot. You might not need to analyze all, you just need some part. So if you want to use just some part of your data set, we create a subset using filter function. Okay. For example, we want to create a subset of data that contains all flight on January 1st. We want just the subset of data that contain all flights on January 1st. The function is called filter. In the bracket, after the bracket, followed by the data set name. Okay, and after that is the condition that we want to filter your data. We want January. January is the first month, right? So we identify month equal to 1, the first month. And we want only January 1st. So the date equal to 1. All right. And you can see here the difference is that the first one, filter blah, 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 we don't create the object. That means after you filter this data set, you cannot recall it. You cannot use it. If you plan to use this filter data, you should create it as the object. Make sure you have that symbols to create the object and identify the object name to something that you can recall it easier. Okay, let's see. We want, let's see the command here. We're gonna create a subset of data right? And we want to create only for all flights information that happened on January 1st. Okay, we want to create that subset. And if we use the filter function, data names, flights, comma, month, we want only January. So month equal 1, comma, day. We only need January 1st, so day equal 1. Right, let's try this one first and see if it runs. With no space, no nothing, let's see. It works, right? It gives you the result here, right? So now you can see the month all in one and day in one. But if you if you feel like this is the result and you want to use it later, we create the object Jan 1st, filter, flights, month equal 1, day equal 1. If you create an object and after you click run, let's see, it doesn't show anything. You have to recall it. And if you want to recall it and show in the beautiful, nice table, you can use view with the capital V in the bracket Jan 1 and run. Now you see that all your data from 300 something thousand, now we have left only 842 records. We filter successfully to contain only the data on January 1st. Any questions, any errors? If you feel like, if you have questions, for example, if I hit the spacebar, month, equal, and then spacebar, add the spacebar, will that affect the result? Well, let's try to and see. Same thing, right? Nothing happens. So in your command line, you may have the spacebar or may not have. That's not the critical issues. But have to say that sometimes if you're very sure that you type all commands correct and you keep getting the error message, you might need to try the spacebar. Sometimes it just works.
Okay, Miss, I'm sorry. Are you showing the our program or the slides?
Our program, I'm
Because
not showing R, is it?
no, ma'am. The it's showing the PPT.
Okay, I'm sorry. Okay. Now you keep it on Studio better. I'm sorry. Okay, let me repeat that again. Okay, we create the subset of data, right, with all flights on January 1st. If you use this symbol and type something after that, you can see it show in the green letter. Of this green letter is not a command, so you don't have to worry. Okay, and we use the function name filter followed by the data set name and the condition that we want to filter the data. And we can see the difference if you just type filter and run. The result will appear in the console area, right? And it show only the first 10 lines, and say here 832 more. That means in total 842. And if you feel like, well, you cannot see everything and you cannot recall it, you cannot use it in the future, we can create an object for that. Jan first, and the same command line. And then you just run. Every time that you create it as the object, it will not show the result. You have to call it. When you call it, you can just call Jan first or Jan 1 and run. And you get the result to appear in the console. But if you feel like this one, you can see only 10 rows, you want to see all of the results, then use function view. View Jan 1. Make sure that V is the capital V. Oops. Okay. No. And now you see the result show in the table nicely with only 842 rows. So still have 19 columns because we do not filter any columns, right? Okay. And let me ask, if we want to know the flight information, okay, I would like you guys to help me create a subset of data with all flights on March 15. How many records would that be? All flights on March 15. I also don't know if they have or not. So I would like you guys to help me identify if there are how many flights on March 15. If you already get the answers, you can share with me and your classmates, okay? Anyone would like to try answer? How many records? Let's see if we get the same answers. THTS. Now month, we want March, so it should be 3. And we want 15. 15. So let's see if there are any flights. Okay. And let's use view March 15. We have 979 flights on March 15. Did we get the same answer? Quiet means yes, right? Yes. Okay, good. All right. So now let's see if we create a subset of data that contains all flights with missing data on arrival day. The flight should have departure and arrival. So we want to know if there are any flights that doesn't have any arrival day recorded. That's the question, okay? So if you kind of like, well, what kind of columns, what kind of data we need to use, we might need to look at all the variables of flights data. We want to filter missing arrival day. So let's see which column should we use. Arrival date. If you guys cannot see everything, we can recall the data to show STR flights to recall all the columns that have in this data set structure flights STR. Okay, and see the results shown below. This is all the variables of the 19 columns. Any columns that feel like that answer the questions? Are there any columns that answer the arrival day? Seems like no, right? We only have arrival delay and arrival time. So let's change the questions. If we want to create a subset of data that contains all flights with missing data on arrival delay, missing data in R will appear as NA. NA, okay? Anything with NA is the missing data in our studio. And we're gonna use the same function, filter flights. Let's create the object missing filter flights, right? That's for sure. And now the condition is missing data on arrival delay. Missing data is .NA. Okay, is .NA on the column name ARR underscore delay, arrival delay. That's the column we want to use as the filter. And click run and see view missing. How many that doesn't have any arrival delay? 9,430 records with no arrival delay. And you can see here the column ARR underscore delay all appear as NA. That means no information, no data, right? That means we really filter successfully. Okay. And that's the filter function. You can use filter to filter out some data and keep only the data that we are interested in for data analysis. Any questions for filter before we continue on? Okay, all right. So we can move on to the next function. The next function is called a range function. Let me type here to make sure that I don't switch back and forth and forget again. A range, that means you want to sort the data in certain way, right? For example, if we want to order your data set by year, month, and day, you want to order your data by year, month, and day. That's our task. Okay. And the function we use is arrange, ARRANGE, right? And then followed by the data type, data set flights, comma, and we want to sort by year, month, day. The conditions that we want it to arrange. And let's use it as the object. Let's call order 1 so that we can recall it to check the answer. And if everything already checked, okay, then run and view order 1. We want things to order by year, month, and day. And you can see that all the records are here, 330 something thousands, right? And start from year 2013, continue on until, because we have so many, a lot of records, 3,000. And then you can see the month start from 1st until 12th, and day start from 1st until 31st. Right? That means we already ordered the data by year, by month, and by day. Let's see. I would like you to help me order the data by departure delay. What kind of commands we have to use? Order the data by departure delay hours. Departure delay hours is the column name departure depth underscore delay, right? That's the column we want to order. So can anyone try and share the commands that you run? Let's call it order 2. How should I type the command? To order the data by departure delay hours. Yeah, we have the answer. Arrange flight depth delay. That, let's see. Flight depth underscore delay. Right, and run. And view order 2. Now you can see that year, month, and day all mixed up because everything arranged from depth delay from the smallest minus 43 and to the larger and larger amount, right? That's correct. But if I add one more condition, to arrange by departure delay hours in descending order. Descending order, that means we want to order from the largest to smallest. Depth delay, what we have to add is DESC in front of depth delay. To tell that we want to order this departure delay hours, but we want to order it by descending order. And C, view order 3. Now we want to see departure delay from the largest, right? Now it's really the largest, 1,301, and continue to be smaller, smaller, smaller. That means we already sort the data in descending order. Any questions for arrange function? Okay, now let's see. The next one is called select function. Select. We already see filter, right? Filter, we filter to get only specific rows, specific records. But for select, we want to use only some columns, some variables. Let's call like some variables or columns. That's the select function. That means all the result 330 something will appear, but it will appear only specific columns that we want to see. Okay, let's see the example to show flight numbers, distance, hour, and minute. We don't want to see the whole 19 columns. We only want to see flight numbers, distance, hour, and minute. Okay, let's call it select 1. And the function we use of course, select. And now we can guess, after select, we identify the data flights, right? And after flight is the condition that we want to select, which is flight distance, right? They have distance. We have flight here, tell the flight number. We have distance. Do we have distance? It's not called distance, but it's called, yeah, it's called distance. And then hour, the variable here, yeah, distance, hour, and minute. And see. Now, how many columns should we see as the result? Flight number, distance, hour, and minute. So we expect to see only 4 columns. Let's see if that's correct. View, select one. And yes, we really see only that 4 columns with all of the records. 336,000 records, but 4 columns only. That's the select function. Okay. Now, if we want to show only columns that contains between year and day. It's a little bit different. We don't specify the column names, but we just say all the columns that appear between year and day. So if we look back at the flight, let's see flight first to recall a little bit. This is the columns order that they show, right? Year, month, day. Our condition now is all columns between year, and day. Let's see. Call it as object select to, and then select function flights. Once we use the word between year and we use the colon, the 2 dots, day. This is the part that represent between year and day. And then just run. And let's see, view, select 2. Now you can see between year and day, all of the columns. That means if you have specific columns you want to see, and that columns kind of like next to each other, you don't have to type all of the column names. You don't need, right? You can use the colon to identify that you want it from this column to these columns. That means, let's see, if I want all of the columns between carrier to destination, if I want you guys help me to show all columns between carrier and destination. What would be the command line that I should run? Anyone? From the carrier to destination, which is DEST column. That means we select 3, select flight, carrier, DEST, between carrier and destination, or from carrier to destination columns. Let's see if it works. View, select 3, right? From carrier to destination. Right? But if it is kind of like next to each other, but you don't want everything. For example, you show all the columns year, month, and day, but you don't want all. Okay? You can add just a small symbol to identify. For example, we want to show all columns except show all columns between year and day except. No, let's see. Let's remove between first. We want to show all columns of the 19 columns except month and day. That means from the 19 columns, we don't want the month and day, so it should show only 17 columns, right? Select 4, select lights, right? We don't want it. We want to exclude that. Just use the minus sign and say month, day. Let's see if the results is as we expected. View, select 4. Now you see the results show only 17 columns. Month and day column disappear. That means you already kind of like exclude those 2 columns from your analysis. What else for the select function? If you look a little bit for the column names and you feel like, well, there are kind of like quite a number of columns with the word depth, like departure time, departure delay, or any columns that with the arrival time, arrival delay, and you don't want to kind of like say it the complete name of the columns, you can just use the select function. For example, to show all columns, that column name contains, let's see, arrival that have the ARR appear on the column name, the column title. Select 5. And select function for sure. Flight information contains. We want any columns with ARR. For this quotation, you can try using the single quotation or double quotation and see the results. Sometimes both work, sometimes doesn't work. So just have to try, okay? Select 5. So now you see, it will show all the columns with ARR, arrival time, schedule arrival time, arrival delay, and also have this one carrier because it have ARR contained in the column name. So if we want to show off the columns that contain departure information, so let's see. Show off the columns that contain DEP. Select flight contains DEP. Okay, let's try use the single quote DEP and see if it works. Sometimes it does, sometimes it does not. And view, select 6. So now you have the 3 columns with DEP. Okay, that means you can use both, right? Single quote or double quote. Any questions for the select functions? If not, there is one more function I would like you guys to try is the mutate function. Mutate function is just to kind of like create the new variables to your data set. Okay. For example, if we want, give this example, form a subset of data containing year, month, day, delay, related information, distance, and air time. How many hours are spent in the air? Okay. Form a subset of data that contains year, month, day, delay related information, distance, and air time. We will create a new variable. No, let's create both. Create 2 new variables. Which are gain, the time that you can save, and speed. And to make it clearer, where gain equals to depth delay minus arrival delay. That's for gain. For speed, equal to distance divided by air time multiplied by 60 to make it become hours. That's the questions. Okay. Form a subset of data. That means we have to start from creating a subset of data that contains just specific columns. And after that, we create the two new variables, the gain variable and speed variable. Okay. Any questions for the task? Let me send this to your message to make sure that everyone have the same information. Okay, this is the things that we're gonna do next. Okay, so now we all have the same information what we are going to do. So we have to first start with the select function, is to create a subset. Let's call flight underscore SML, smallest subset of data, and use the select function, flights, right? We only need year, month, day, and we know that year, month, day are three columns that next to each other. So we don't have to type all, or you can type all, that's also work. But if you kind of like a little bit lazy, like me, you can just use the colon to specify that you want the year column, the month column, and the day column that happen to be next to each other, right? So we have these three. And then we want all delay related information. So the next condition is contains, right? We want contains DEL, is it delay for delay? DELEY. That means we ask the program to scan all the column names and show all the columns that contain the word delay. That's the second part here. And then we also need the column distance and air time. Distance and air time, if we look at our information, the flight information, air time is here and the distance is here. If you lazy, you can type 1 time 2, just like we do before. Or if you want to specify, also work distance, air time, right? Or if you're lazy, you can just use the colon. But if you use the colon, make sure that you start with air underscore time followed by distance, air underscore time. Okay, let's use as the lazy one, air time, colon, distance, which is just 2 columns anyway. Right? Do we have all the information first to create a subset? Yes, we use select function. And in the select function, we want year, month, day. Year, month, day here. Delay related information. Delay related information, we use the contents and the distance and airtime columns, which is here. So we have all of the columns we need. So now we can click run, create the object first, and see if it is as we want to create flight underscore SML. Yes, you have year, month, day, delay related information, right? Departure delay and arrival delay. And you have airtime and distance. So that's the first one, done. Now we want to create the two variables, the gain and the speed. We're going to use the mutate function to create that. So from flights SML, we just want to add the columns into the same data set. If we want to use it the same data set, you can use the same name. It will overwrite what we have created first. That means hold on, I cannot see the whole message. We may continue the material until 11. After that, we will have discussion. Oh, okay, so I have time until 45, is it? Okay.
Yes, Miss.
All right, that also works. So let me share the PowerPoint slide here. Okay, so that's the PowerPoint slide. Okay. So now everyone have the answer. You know for sure that we're going to use mutate function, flight. But now we don't use the whole data set. We want to,
Miss,
yes.
I'm sorry, did you send the file directly to me or to all the participants?
Oh, I sent only to you. I'm sorry. That's correct.
Yes.
Okay, let me send to all. Or can I send after that?
Okay, yes.
No, never mind. You can send to everyone now to have the answer and then we can type along. Okay, now
Okay,
it should
thank
be
you,
to
Miss.
everyone. All right. Sorry. I thought that I have time until like the complete 2 hours until 11. All right, so let's finish this one. I think we have enough time to finish this one. We first have the subset of data contain only specific columns that we interested in. And now we want to create the two new variables, the gain variable and the speed variable, right? For the gain variable, it's not happened yet. So we have to type to let the program know that our gain equal to depth underscore delay, right? And minus by arrival delay. Just tell it directly that from this data set, the SML data set, we're gonna add one more variable and that one variable name gain. And gain equal to depth delay minus by arrival delay. Okay, the first one done. And then create the second one, speed equal to distance divided by air time multiply 60. The two new variable already identified, right? Using the mutate function. And now let's run. Pray for no error. You can type in the same line. If you feel like it's okay, you can type in the same line. If it's not, or you get the error message like this one, make sure that you check for all of the accuracy. Oh, I don't have the air time. It's incorrect, this part. No wonder I get the message here that object air time not found. Every time if you get the error message, try to find out what is the error that you have done and try to fix it. Like this one, they cannot identify air time. So I recheck the name. It is air underscore time. You can continue, for example, in the same line that also work. Flight delay. Okay. Also work. But if you feel like it's a little bit messy and some people feel like it's messy, we don't like it, you just hit enter. And if it is behind the code, the comma, it will arrange in the kind of like nicely format for you to see and then click run again. This time no error. Right? And now let's see the data we have created. Flight underscore SML. And run. So now you can see from year, month, day, date, delay, arrival, delay, airtime, distance. Now you have two more variables. And it's compute for us as we identify here. And that's the mutate function. So if you already have existing data sets with all the columns that you need, and you kind of like do some computation and you want to keep it in your data set, like when you work with SPSS, you also can use the mutate function to do that for you. And that's for the mutate. Any questions so far? And just one more function, that one easy. You can just kind of like group off the data by certain characteristics, certain conditions. You can just kind of like follow from the PowerPoint slides that I have shared to you and see how it works. Okay. And that's pretty much it for the data transformation using RStudio. Any questions? And there actually there's some small exercise that you can try. The last slide on the PowerPoint. Yeah, this one. You can try, collect. After we already use all the functions for data transformation, you can try if you want to filter, to sort, to select, or to mutate. Yeah, that's pretty much for me today. Any questions?
Okay, everyone, is there any questions or maybe some parts of the matter that you still don't understand or maybe you left behind on the tutorial? You may deliver the questions directly, maybe by turn on your camera, or you may send to the Zoom chat.
Any questions? No questions?
Okay, any questions, everyone?
Or if you have questions after today, you can email me. No problem at all. Okay,
Okay.
let me share my email address in case. If you run into any problems, any error using our studio, you can email me anytime, okay?
Okay, everyone, you may save the email address of Miss Suparak for further questions. Maybe if you still don't, if you may have problems in your R programmings. And maybe thank you very much, Miss Suparak, for the wonderful materials for our students. So maybe it is very important for two students nowadays to learning for technology and also informations, especially for your thesis, because some of these students, they are senior student that will finish their thesis. And I think conducting research in accounting technologies, maybe by utilize the R programming, is very interesting and also a wonderful topics for everyone. Maybe you may get inspired from this seminar from seminar today's. Maybe we will close for the material sessions, and the MC will continue the events.
All right. Thank you, Mr. Ardi, for to lead the seminars, and then thanks to Ms. Suparak Janjarasjit, Ph.D. for the attractive material. Hopefully, it can help the audience to have a better understanding of data transformation. Before we close the agenda, as the master of ceremony, I do apologize for any mistakes. Before leaving this event, kindly please everyone to turn on your camera because we want to take a picture. Okay, please everyone, you can turn
Everyone,
on the
please
camera.
turn on your camera. We will have documentation sessions.
Okay.
Okay.
Okay,
Abdur, please open your
yes.
camera, Abdur. Maulana, Jasmine.
Okay, everyone, please turn on the camera. Okay, ready? I'll count. 1, 2, 3. Okay, once more. 1, 2, 3. Okay. Thank you for joining this event and see you in the next event. I close this program. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Miss
Thank you, Miss.
Suparak. Maybe
Thank you,
someday
Mr.
we will meet in an event, maybe directly.
Yes. Thank you.